Welcome everyone to this uh, Tech Talk. We're doing these twice a month, usually pretty casual, just talking about one or two particular technologies around the MLAI fields. So, welcome and thanks for joining us. You can always find them afterward, either on our any of our tech support channels, and our YouTube has all the videos and everything that we record there. So feel free to catch up on any of the backlog. Anyway, today's is going to be a little different and pretty fast, and I want to say casual, I guess. Uh, what we're going to be doing is just talking a little bit about one particular use case in AIML, face recognition, a very, very common use case. And we'll be kind of going at it from the perspective of not a data scientist. I mean, face recognition is such a common use case. Everybody wants to do it. Everybody has done it. And so it's kind of one of those, I could work on it for as long as I can on my laptop. It's not going to, I'm not going to improve on face recognition algorithms that are out there. So I just want to use it. And that's kind of the perspective that we're going at it from today. So let's get started. First of all, we'll just talk about why a little bit. I think everybody knows why, but why would we want to use AI to recognize faces in imagery? It is, it's a problem that's not traditionally solved with normal computer science. There isn't an algorithm, a mathematical way of saying, hey, these pixels right here are the face of a person or an animal or anything. So AI is the way to solve that. And why do we want to do it? We want to locate faces in images. Maybe we want to locate features, eyebrows, nose, chin, mouth. We want to know where those features are within the image. And then maybe we want to identify that image itself. Who is in the image, what they're, potentially even doing some sentiment analysis or something. Is this person happy? Is this person sad? And yeah, what is their name? Just a few random use cases, but let's just dive into it. Again, today, no slides, nothing like that. We're going to go straight into the code and present this use case. And as I mentioned at the beginning, I want to focus on more the developer, the user, somebody who's going to end up using this. So we're not going to develop our own facial recognition algorithm. We're going to leverage resources that are already known, like dlib. Dlib's just a C++ toolkit that very smart people put together, very well documented, and does a whole lot of stuff. We're talking, stuff that if you're not a machine learning, if you're not a data scientist, you might not know, but we've got vector machines, we've got SVMs, we've got radial bias function networks. I don't know what some of these are, but what we're really interested in is that they have high quality face recognition. So I want to use this library that's been trained on, I don't know, thousands, maybe hundreds of thousands. But when I click through it, it is very well documented, but this is still C++ code. So as usual, I'm not that interested in that. So I'm going to jump back, and I know that somebody has actually taken dlib and packaged the facial recognition into a pip installable library. So what can I do with this? Pip install face recognition, and hopefully I'm off and running. Now I have a library that has been trained, that has been tested, that works really, really well for all of my use cases, and I didn't really have to do any work. The other resources I'm going to use are Chassis and modsy.com. If you've ever attended one of these tech talks before, you know that these are pretty common. We know how to use them, but I'll go over those a little bit more in depth as we hit there. So first of all, I want to grab an image. This is two random people. I don't know who they are, but I do know that this image is public domain. So what I want to do is figure out where the faces are and potentially use some of the other resources like landmark recognition, all that. Mentioned pip install face recognition. That's it. That's what you have to do. I've of course already done that, so I'll skip over that step. But we're going to import it and just try it out. No particular requirements here other than running face recognition. So here I've got the locations of those faces as just coordinates within that image, so it looks like it's working. And just because I know this library has landmarks, we'll try that out. Look at that. We got chin, eyebrows, noses, eyes, everything interesting. And then the last thing that this library does really well is these face encodings. So what this does is looks at the face and comes up with a nice fingerprint for that face, so I can then compare that fingerprint across various photos and hopefully identify that face, even if it's completely different lighting, different resolution. It should be able to fairly well identify that face across images and match them. That's this algorithm, if you drop into dlib and really read some of the documentation, it's looking at stuff like distance between the eyes, length of the nose, length of the mouth. It generally works whether you're wearing glasses or not, in just about any lighting condition, just about any resolution. Even if the face is blurry or very, very sharp, it'll often come up with a very similar fingerprint, which you can then use to compare. So great. Again, I've done all this with very minimal effort, just using out-of-the-box libraries. So what I want to do next is combine all three of those functions into just a single function. I've got my face locations, my face landmarks, my face encodings. Each one of those are happening as one thing, and then I join all those together into an object to return it. The only other interesting thing I'm doing here is I'm actually using a byte array rather than file location. And this is for a bunch of reasons, but mainly I want to run this maybe on S3, maybe on someone else's laptop. Maybe I want to pull in images from the internet rather than having them locally. So I don't want to use just a file location there. So I'll pull in the byte array, but transform it into a file-like object, and then run the algorithm on that. So let's go ahead and try it, because I love to try every piece of code. We open it up, we turn it into a byte array, and then we feed it through that function up there, which gives us the result we expected. A location, an encoding fingerprint, and then all those features and landmarks that we find in the face with their locations. So great, it's working. But this is working on my laptop. It's working, in a Jupyter notebook. All this is very, I'm going to say, not very useful to other people. And it's not very useful if I wanted to, say, make it into an online service or monetize it or use it tens of thousands of times a second. Maybe I want to run it on AWS, that sort of thing. So what I want to do is actually publish this model so that it's available as a web service. I'm going to use Chassis.ml for that. Those of you who know Chassis.ml, you probably love it. If you don't, come to Chassis.ml. You have two options. You can, you can install it right on your machine. This is open source. We provide nice instructions, but we are helpfully creating a free Chassis service that you can connect to just over the internet. Sign up here, and we will give you your own little URL, and you can submit anything you want to Chassis for free. Special thanks to Google for helping us out with that. So jump over there. What Chassis needs is what's called a process function. So this is the simplest process function you could imagine. I'm going to pull in those image bytes and call that same function that I defined up here, and then I'm going to take that output and put it into a structure. Simplest process function you can imagine. That's all I'm going to do, and I'm going to test it. But of course, we're expecting exactly what we saw up above, so that works. So next I'm going to run Chassis. It is another pip installable library. I'm going to create a client with that particular URL that you'll be provided with if you sign up. And then I'm going to create a chassis model using that function that I just defined up here. And that's it. I'm going to test that. Lo and behold, I get exactly as expected, maybe formatted a little differently, but this is still the location, the encoding, and then all of those landmarks like the chin and the left eyebrow, and everything's there. So it's working. I now have a chassis model that I built from a pip installable face recognition library. This took 5 minutes or however long it's been. Very, very simple. Next step, I want to publish that model to an actual web service. I can run, I can package it up into a model and push it to Docker using my Docker username, Docker password, or if I have a Modsy account, like on app.modsy.com, if I'm paying for the Modsy Basic Plus, I can just push a model straight to that and have it available pretty much immediately. For this particular one, it does take a little over 10 minutes, so I ran it ahead of time, but we see that it was successful. It pushed it up there, and actually if I go over to app.modsy.com, go to models and my models, there's the one that I pushed up this morning. We can see, we've got all our, I still need to fill in all my documentation, that sort of thing, but we do have an example API request and an example API response. So this model is available and ready for use. So my next step would actually be to publish it. This code right here, I'm just going to delete that. We're going to run back over, grab this code here so you can see I'm just copying the existing template boilerplate code. The only changes I need to make, let's add our API key here. Which I may not have actually imported yet. So let's pull that in as well. And then the other change that I need to make is the input file that I want to run it on. So let's run back up here. What was the name of that? The image path. It's a good name. From there, I can actually execute that job. And we see that we get a nice identifier. If we run back over here, check out our operations, we have, in fact, it's already completed, but there's our job with our input. It took about 1.9 seconds. And again, we get that nice location, encoding, landmarks, everything is available. So back in our notebook, we check out if we can grab the results, see the exact same thing. Fantastic. So now I've taken that pip installable model, I've wrapped it in a very minimal wrapper, and I've created a web service that is available for anyone to use. If you distribute it, if you make it available, anyone that you want to use it. So throw this into an app or something, run it on on your iPhone. Doesn't really matter as long as, if it can make a curl call, if it can make a REST call, if it can run Python, JavaScript, Java code, all of that is very, very simple, and you can just run it pretty much anywhere in the world. And now it's going to be auto-scalable. We're going to monitor it for drift. We're going to monitor it for how much it's being used, who's using it, all the features that you get with Modsy backing that function. So what can we do from there? Well, we mentioned before we could blur faces. So this, again, is we're pulling that image in, that image path, and then we're pulling those results from the previous function. And we're just going to blur some faces. So in this, you could rebuild something like the Masquerade app that allows you to take any photo on your iPhone, recognize the faces, and blur the ones that you don't want shown, or throw an emoji over the top of the face. This is especially useful, if you have kids who, maybe you're publishing playground photos, but you don't want other children to be pictured in those. If you happen to be, out and about, but you don't want the strangers in that photo, if you don't want their faces on your image, or, who knows what reason. Very, very useful. And all we've done is called a web service that we made available, and then use those results to change that images. We could also plot the features, exactly the same as before. We're pulling in that image. We are pulling in those results as from before. We're drawing the same square that we were before, but now we're adding in landmarks. So if we draw this, look at that. You can make people look nice and funny and have a lot of fun with them. I've seen some web services that will automatically add makeup or make you look like a clown, or maybe make your own Animoji in the spirit of Apple and iPhones. But all that's available. And then, of course, the last use case is recognizing faces. In this, maybe there's a photo and we don't know who they are. I actually meant to swap these out. Instead of stars, I was going to use these two unknown individuals up here, but apparently we got our changes reverted. Anyway, I pulled each of these images off IMDb. It's just the main image from IMDb, and we can take them, and feed them through the algorithm. This will submit each photo to Modsy. We can see that over here. It'll have each photo's input name and then each photo's encoding. We're going to pull that encoding out and save it out to our database with the labeled name from IMDb. And then what we want to do is take some other random photo that may or may not have their faces in it. This is significantly older. Most of those IMDb photos, with the exception of Brad, are 10, 15, 20 years aged, but we're going to hope that doesn't make a difference. So this, again, we're going to feed it into that algorithm when it is correct, and I didn't accidentally make a typo here. Yeah, I think I touched something. We see that job, again, completed. We just have one job with an unknown name, but we recognized a bunch of faces in it. And let's see exactly what faces we recognized. Looks like we got 5 of them. So we're going to set a tolerance and compare those faces that we got out of that photo using this algorithm to the faces that we recognized before from the IMDb matches, our labeled data. And we see that, hey, we actually got 5 matches. What did we do? Well, looks like we did pretty well. We got George Clooney, we got Brad Pitt, we got everybody here properly recognized based on just an old photo. So you can be as creepy as you want with that. I also ran it on a team photo of everybody within Modsy, and it worked surprisingly well using nothing but our Slack and LinkedIn images. You could set up a web service that allows folks to recognize their family members or something like that. You could run this on the background instead of iPhotos built in. You could do just about anything. Now that we've published this particular algorithm, it's not just available on my laptop or my system. It's now available anywhere that I can access the internet and anywhere that I can run it. And the whole thing took maybe 5 minutes to execute. We packaged up that pip model, created a process function, used Chassis to publish it out to Modsy so that now any service that can use a REST call can make use of this particular model. Again, it's auto-scalable, drift monitored, secured, all of that. So now if I wanted to run this model 10,000 times an hour, it would auto-scale and be just fine with that. So you could replicate this entire process, just sign up for app.modsy.com, sign up for the Basic Plus, and you can do this whole thing, publish your own model, and then run it a couple thousand times a day if you feel like. And that's all there is to it. So if there aren't any questions, we can end this, and I'll give you a few minutes back.